Alright, with this video we want to start with a question that probably you've never really thought about before, and that's this. How is it that we can measure the temperature of something? Why is it possible that we can measure what temperature something is? That's the question for this video. Let's get started. First off, what is temperature? Well, I'm not totally sure we've defined it yet in these videos, but basically temperature is equal to the amount of energy. It's a measure of the kinetic energy that something has in the molecules. So basically it's a measure of how much energy is contained within the molecules of the substance. So basically temperature is a measure of kinetic energy within the atoms or molecules of that substance. So how can we measure the temperature? Well, basically we have to have some way of measuring the like a property, some property that we can measure. We can't measure how much the molecules or the atoms are actually vibrating. We can't really even, for most practical purposes, see the atoms or the molecules. So we have to use some bigger properties than that. So what we need is some kind of property that changes in a linear fashion, right, in a predictable fashion based on the temperature of the substance. All right, and that's what we have here. So we're describing the fact that we basically have to use some property of the material that changes when the temperature changes. And it has to change in a predictable or linear fashion in order for that property to be useful to us. All right, so here are two examples right here. All right, electrical properties of materials and infrared radiation, which we'll talk more about types of radiation later, but infrared is a certain type of radiation. It's not like dangerous radiation, all right? This is like, it's on the electromagnetic spectrum, which possibly you've studied before in other classes, but basically it's, if you take visible light, the red, orange, yellow, green, blue, on that spectrum, just past red, there's this type of electromagnetic radiation that is called infrared. And everything that's got any kind of heat gives off infrared radiation. And if there's more heat, it gives off more of it. So if you have a device that could measure that, bam, this gun, shall we say, it's not actually a gun, but it fires off a little laser beam that can measure how much infrared radiation there is, or maybe it's not, whatever. It basically can sense the amount of infrared radiation that's being given off. It's like a little camera thing in the front there. And that then, you've got electronics in here that interpret that and convert it into a number that you can read. Dude! So this device is expensive. It's called an infrared thermometer. You can even see that printed on the side there. Let me zoom in on it. It's a little bit hard to read here, but it's an infrared thermometer. Alright, so it measures the infrared radiation being given off and interprets that as a number. This, most of you are probably familiar with. It is a digital thermometer for taking your oral temperature. So that end goes under your tongue. You hold it there for a while, it beeps at you, and it tells you your body temperature. And then you can find out if you have a fever. So how does that work? Basically, there are electrical properties that are sensed by this. The temperature is sensed by this guy here. This becomes the same temperature as your mouth. That then communicates with some electronics in here, and based on properties of those materials, you can end up getting a reading on there. It's not that super important that you understand what's going on inside these devices. Just the fact that they both use some property of materials that changes when temperature changes. All right, a couple more examples. We've got here, these examples make use of expansion or color change. So let's start with the color change. You'll notice somebody has put their hand on this material, and what happened? The color changed from pink over here to a whitish color. Obviously this is not a thermometer. I tried to find a picture of like one of those forehead thermometers that change color when you stick them on your forehead, but I couldn't find a picture of that, so I went with this just to illustrate the concept. Sometimes some things change color, and they change color in a specific way based on the temperature of the thing that is touching them. So in this case, this pink color turns more whitish when it gets hotter. All right, so colors can change, and that can be used to measure temperature. This one involves expansion. This is the type of thermometer that I'm sure you're very familiar with. Inside here there is alcohol, and then that's in the bulb, which has a thin glass around there. The rest of this is very thick glass with just a thin tunnel that the alcohol can expand up into that. So what actually happens in this thermometer is that as the alcohol gets warmer, it expands, because remember we talked about when things get warm or things get hotter, they expand. And then there's only one place for the expanding alcohol to go, and that's up this tube, right? This very, very thin tube. We can't see the top of it, but basically the hotter this gets, the further it goes up the tube, because it's expanding, and there's only one place to expand, and that's up into this thin tube. So then you can just mark on the thermometer all of these little increments, and you can tell by how much the alcohol expanded, you can tell what the temperature of the thing is that you're measuring. And that is super cool. This is another thermometer that makes use of expansion. We're going to see an example, a demo of this in class. But inside here, there's what's called a bimetallic strip. It's basically a strip that has two metals on it. So let me just give you a really quick, rough little diagram here. Basically, you've got like a strip. It's a very thin strip. I'm going to draw it thick because I just can't draw it thin. But it's actually very thin. And they're two metals that are essentially welded together. They're stuck together like this. So this is the strip, one kind of metal here, different kind of metal above it, different kind of metal, and they're bonded into this strip. So they're going to expand when their temperature changes. If they heat up, they expand. And basically one of these metals will expand more than the other one. But since they're bonded together, that's going to cause this thing to bend. So when it heats up, add heat, then this thing's going to bend. So later on it might look like something like this. Right, there's this expanded more than the red one. Right, so the thing bends. Kind of like that. All right, and that you can make use of this property of a bimetallic strip in order to cause basically this reading, this needle will twist based on the bimetallic strip that's inside there, how much it bends. It makes this twist around, and then you can see how hot your meat is and see if it's fully cooked or not. Okay, last point. When we're trying to measure temperature or set a scale for measuring temperature, basically what we need to do is we have to have a couple of points that we know what their temperature is. And in fact, what we're going to talk about here is the basis of the Celsius temperature scale. So Celsius is defined in terms of two things. They define this as 0 degrees, and that's the temperature of melting ice. And then we define this as 100 degrees, and that's the temperature of boiling water. Now, it's important that the ice is actually melting and that the water is actually boiling, because then you know exactly what temperature they're at. So Celsius scale, we call these fixed points, by the way. Fixed points. Ice always melts at the same temperature, and water always boils at the same temperature. Now, if you have ice that's not melting, it could be at a whole bunch of different temperatures as long as it's less than 0, right? Water could be, well, steam, let's put it that way. Steam could be at a lot of temperatures if it's under pressure in a container, right? And it can be more than 100 degrees. But if ice is in the process of melting and if water is in the process of boiling, then you know what temperature those are. So we can use these temperatures, they're called fixed points, in order to set a scale. So basically, you might take a thermometer, stick it in the ice, right? Call that a thermometer. Dun, 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 dun. And then we might mark on there the temperature reading on the thermometer for the ice. So let's just go off to the side here. So we have our thermometer. near, whoops, near thermometer, whoosh, and in there is some red liquid. Near. All right. So then let's say this is the temperature of melting ice. So we would then, we've got this in the melting ice, this is the temperature, so bam, we call that 0 degrees. And then later on, we stick the same thermometer into some boiling water, right? So now we're in here later, all right? So this is, let me go over here. This is ice. And then we go back to the water later, we put it in the boiling water, and we measure that temperature. And what happens? This goes up higher. Now we're settled, we're set, and then we have this temperature. So we mark that on the thermometer, and we call that 100 degrees. All right? And that would be the temperature of boiling. Gosh, I can't write with my finger. Boiling. All right, anyways, whatever, you get the idea. That's totally messy. Okay, so these are fixed points, all right? Fixed meaning that they never change. If you have boiling water at sea level, then you know it's going to be this temperature. If you have melting ice pretty much anywhere, you know it's going to be this temperature. So then you can use melting ice in order to mark that temperature on a thermometer if it was not marked already. And then you could use boiling water to mark that temperature on the thermometer. And then basically you just need equal increments in between. You just basically break it up into equal chunks and you have your degrees. Split this into 100 markers in between. Bam! You have a thermometer. That's basically the way that thermometers have been designed, and that's the way that the Celsius scale was invented. All right, so the guy who invented it, he just took he decided that he knew that melting ice was always the same temperature, and he used that as one point and called it 0. He knew that boiling water was always the same temperature, so he called that a different point and called that 100, and then he just filled in with 100 increments in between them, and bam, Celsius temperature scale was born. So that's fixed points, and that's how you're able to make a scale of temperature. All right, this was kind of long. Sorry about that. Hope that helps, and that wraps up this video.